All right, so we've got two functions here. It says solve for p of x is greater than q of x. And we're going to use our graphing calculator to help us out. And we're going to graph each of these and see where p is greater than q. Okay. All right, so let's graph it. And so in here, I've already typed in the two equations, and you can go ahead and pause and type those in now. But I'm going to graph them. And actually, let's change my window to not being a useful. So we're going to go to window or zoom standard and make it kind of a not useful range. So right now it's graphing the points, and I can't really see what's going on, and so I'm gonna cheat a little bit and change my zoom to zoom fit, and hopefully that'll make it all fit in as it graphs it. So it's going to go ahead and change that for me slowly, and now I can see more of the graph. But as I kind of look at it, there's a lot more going on in here that's kind of getting squished into that x-axis, so that doesn't work very well either. But let's be smart about it, and so I'm going to go to my window and see what happened. And the calculator changed my x value. Didn't really change that much, but changed this to the thousands. So maybe if we just try changing it to -100 and +100 and see if we might be able to graph it at this point. So one more time, graph. And now here it is in kind of a much more useful situation. So the first graph, and maybe to be more explicit about it, we'll only graph one at a time. So the first graph is going to be the negative x cubed graph. And that looks something like that there. It looks like it's heading on down, has a couple roots, and we could find those. Heads up, and then heads back down again over here somewhere. And I'm just being very unspecific because we don't need to know all the fine detail, just trying to figure out what is generally going out. So it's going to be coming down. That's going to be my blue one. It's going to head down below, head back up, head down again. So here we go. So heads on down, comes back up, and heads on down, heads up, heads back down again. Negative x cubed. And the positive, or sorry, the red one, not positive, but the red one is going to, let's graph that. It's going to come up close to the same point, head back down, and then head up again. So it's looking something like this. And again, not a perfect graph by any means, just trying to figure out a little bit what's going on. And so we're looking for where P of Q, where blue, is greater than red. And so hopefully we can see that just by the sketch that right here, the blue graph is, the output is greater than the red graph. If I plug in the same x values, the blue graph comes up with a greater output. Also, right here in this little trough, P of x is going to be greater than Q of x. And so what we need to do then is find these locations right here, and we'll be able to figure out what our boundaries are and what our x values are going to be. So to do that, we're going to go back to the calculator and use the intersect function. So second calculate, and we're going to head on down to intersect. It says get on the first curve. I'm just going to go a little bit to the left of that intersection, hit enter, and then the second curve, same idea, a little bit to the left, and hit enter. Now it will tell me what that intersection is at, and it says that it's at 1 to the negative 1.8 to the negative so on to the and then y equals 4. Now this 1.886 to the e to the negative 16, that's really just trying to tell me it's at x equals 0. And so our first boundary is that x is less than 0. That's going to give us, wherever x is less than 0, our blue graph, the p of x graph, is greater than q of x. And it's going to continue on until we get to this boundary over here. So again, you're going to hit second, calculate, head on down to intersect, and get close to that point of intersection. And this time it's going to tell us at the x value of 3.76. It tells us where the y value is as well, but all we really are caring about is the x value. So 3.76. 3.76. Now that is not included because we're not looking for or equal to, but x is going to be greater than 3.76. And now let's find our last one. Our last point of intersection is at it is going to be at 8.2. All right, 8.2. So again, this was 3.76, comma, whatever the y value was. This was 0, comma, I think the y value there was 4. And here we're at, oh, I forgot, 8.23. 8.23, comma, whatever the y value is, so less than 8.23. And here's our solution set. The solution of where p of x is greater than q of x, well, when x is less than 0, and when x is between 3.76 and 8.3. All right, hope that helped.